Welcome back to The Explainer. So today we are strapping in for what is, quite literally, the greatest construction project in the history of the universe. I'm talking, of course, about the creation of our very own home. 4.5 billion years ago, the ground beneath your feet simply did not exist. There were no oceans, no mountains, no animals, not even a single drop of liquid water. So today we're tracing the exact, miraculous, and incredibly violent steps that built our world.
I want to ground us right away in a truly mind-bending reality here. Everything you know began as cosmic dust. Take a second to really internalize that. Every towering mountain range, every sprawling city, the deepest oceans, and yes, even the very cells of your body watching this explainer right now, all of it started as microscopic space debris just floating around in a dark, empty void. Okay, let's dive into this. How exactly did a dark, freezing cloud of loose particles transform into the vibrant, living planet we call home? It's a question that has puzzled humanity for centuries, right? But scientists have actually pieced together this remarkable chain of events. It's a massive chronological journey, and the whole shebang starts in the darkest corners of the Milky Way.
Section 1, From Stardust to Star, the Forge of Our Solar System. To really understand Earth's birth, we have to rewind nearly 5 billion years. Imagine our region of the galaxy as nothing but a massive, floating cloud packed with hydrogen gas, helium, and tiny particles of dust. Crucially, these materials were just the leftover scraps from ancient, massive stars that had already lived their lives and died billions of years earlier in catastrophic explosions, supernovas. Well, when a nearby supernova exploded, it sent a massive shockwave crashing right into our gas cloud. It didn't just collapse the cloud, though. It acted as a cosmic forge, scattering iron, silicon, oxygen, carbon, and gold across space. So the literal atoms in your body today, they were forged inside those ancient exploding stars. You are quite literally made of stardust. So because of that intense shockwave, the cloud collapsed under its own gravity, pulling all this material to the center and spinning faster and faster. The pressure and heat reached millions of degrees until, boom, nuclear fusion ignited. Our sun was born. Now, the sun is a cosmic giant, hogging more than 99% of all the mass in our entire solar system. Whatever was left over formed what scientists call a protoplanetary disk, basically a giant, swirling, rapidly spinning cloud of leftover gas and dust just orbiting this brand new star. And this brilliantly illustrates what happened next. Inside that spinning disk, a highly chaotic chain reaction kicked off. Tiny dust particles, literally no bigger than grains of sand, began bumping into each other and sticking together. Over immense stretches of time, gravity helped them grow. Grains became pebbles, pebbles crashed together to form rocks, rocks accumulated into the size of mountains, and eventually those mountains smashed together to form entire worlds. And one of those worlds was a very young, very volatile Earth. Section 2, Forging a Violent Planet. A world of liquid rock. Now, you might be picturing a quiet, peaceful rock peacefully floating through space. But early Earth was a hyper-violent environment. It was being shaped by countless, high-speed collisions happening every single second. Massive rocks slamming into the planet at incredible speeds released immense amounts of energy, causing the young planet to steadily, violently grow in size. And those relentless collisions generated heat, unimaginable heat. The temperature of the young globe spiked to over 2,000 degrees Fahrenheit. The entire surface of the planet just melted. Earth transformed into a giant, literal ocean of boiling lava. It was an absolute hellscape where absolutely no life could ever survive. But surprisingly, this catastrophic heat was actually a vital step in our planet's engineering. While the Earth was completely molten, a crucial sorting process took place. Think of it like a giant cosmic centrifuge. Gravity pulled the heaviest elements, like iron and nickel, straight down to the center. Meanwhile, the lighter materials floated up toward the surface. This sorted the Earth into the foundational layers we know today, the core, the mantle, and the crust. And why does this matter to us? Because that incredibly dense iron core generates the magnetic field that to this very day acts as an invisible shield, protecting us and our atmosphere from deadly solar storms. Let's move to and see how this builds, because just as Earth was kind of finding its footing, disaster struck. A Mars-sized planet named Theia collided directly with our young world. The impact was so catastrophic, it vaporized massive regions of both planets instantly, blasting trillions of tons of glowing debris out into orbit. But from that immense destruction came life-saving stability. That ring of debris eventually clumped together to form our moon. And this new partner immediately went to work, stabilizing our chaotic rotation and creating the ocean tides, which, as we'll see, became absolutely essential rhythms for the life that was yet to come.
Section 3. The arrival of water. Cooling the hellscape. At this point, we still have a massive problem on our hands. Our planet is essentially a molten ball of lava covered in impact craters. So, how do we get from that to the cool, habitable oasis we live on today? It poses a grand scientific mystery that puzzled researchers for a very long time. Where exactly did Earth's water actually come from? I mean, it's wild to think about. If the planet was a 2,000-degree ball of liquid rock, how on earth did it end up filled with vast, deep oceans? Any water should have literally boiled away into space instantly. Well, the answer is an incredible multi-source delivery system. First, scientists now believe some water was actually trapped deep within minerals during Earth's initial formation, and it slowly outgassed as steam. Second, over millions of years, the planet was bombarded by icy asteroids and comets, which basically acted like giant cosmic water balloons crashing into the surface. As the Earth finally began to cool down, all that water vapor in the atmosphere began to condense. Thick clouds formed, and then it started to rain. And it didn't just rain for a weekend. We are talking about a colossal, continuous rainstorm that lasted for thousands of years. Now, what's really interesting about this slide is the sheer contrast. We went from a planet covered entirely in oceans of boiling lava to a world where those millennia of rain filled up the lowlands, creating oceans of water that now cover a massive 70% of Earth's surface. For the very first time in its violent history, our planet was actually starting to resemble the beautiful blue marble we recognize today. Section 4. The Spark of Life. From Microbes to Humanity. So, with the cooled crust and vast, nutrient-rich oceans now in place, the ultimate chemistry experiment was about to unfold, the transition from a sterile, rocky globe to a biological haven. To put this massive journey into perspective, let's trace the timeline. 5 billion years ago, we had that collapsing gas cloud. 4.54 billion years ago, the Earth itself forms. And then, right around 3.5 to 4 billion years ago, deep in those newly formed oceans, the very first invisible, microscopic living organisms appeared. From those tiny microbes to the complex life thriving today, it is an unbroken, incredible chain of survival. These ancient microbes were tiny, sure, but they fundamentally transformed our world. They began performing photosynthesis, taking in sunlight and releasing oxygen as a byproduct. Over millions of years, they steadily pumped out more and more oxygen, completely changing the atmosphere's makeup. This atmospheric shift is what absolutely paved the way for complex life. It made it possible for fish to swim, for plants to conquer the land, for dinosaurs to rule, and eventually, for humans to build societies. 4.54 billion. That is the exact age of Earth in years. It takes that immense, almost unfathomable amounts of time to properly engineer a planet like ours. To forge a dense iron core, to generate a protective magnetic field, to suffer a planetary collision that gives us a stabilizing moon, and to gather enough cosmic water to form climate-regulating oceans. I really want you to remember that the next time you look outside your window, every mountain you hike, every river you cross, every forest, and every city skyline is the direct result of these countless, perfectly timed, extraordinary events. Earth isn't just some random rock we happen to live on. It is an incredibly complex, meticulously crafted system. And I'll leave you with this final thought today. We are not separate from the universe. We are one of its greatest creations. The ground beneath your feet, the water you drink, and the atoms in your body are all tied to a cosmic journey that started in the dark vastness of space. But looking at how many chaotic, violent, and miraculous coincidences it took just to build this one habitable world, you really have to ask yourself, are we the only ones? If you want to keep exploring the wonders of our universe and uncover more incredible stories like this one, make sure to subscribe for more fascinating visual explainers. Until next time, keep looking up.